So physically what's happening here is we have a sample of ice below the transition temperature, so we need to warm the ice first to the transition temperature of 0 degrees C before it'll melt. Then heat will be used to melt the ice to liquid water at 0 degrees C. So we could calculate the heat involved in each of these first two processes, subtract that from the amount of heat that's provided, and any remaining heat is used to raise the temperature of liquid water. So here's the calculations to calculate the heat used to raise the temperature of ice up to its transition temperature, the melting point, 0 degrees C, and the second amount of heat needed to melt the ice to liquid water. So both of these values need to be subtracted from the amount of supplied heat that we're given, and we now know how much heat is left over to raise the temperature of the water. And here we are at our result. So we take this amount of heat that's left over, we determine the temperature change that can be achieved using this amount of heat, and we add the temperature change, delta T, to our initial temperature, which is 0 degrees C. So we have our final temperature of 41 degrees C. Now in terms of sig figs, we see we can only have 2 sig figs here, so this is good to the ones place. 3 sig figs here, so this is only good to the tens place. So when we do the subtraction, this value is only good to the tens place, meaning 2 sig figs. So 2 sig figs.